Welcome to this episode of our videocast series by the Schaufeler Lab at TU Dresden. My name is Jasmin Hoening and I am a PhD candidate in art history and a research associate at the Schaufeler Lab. The Schaufeler Lab is an interdisciplinary collaboration and exchange between PhD candidates from the humanities and social sciences and also residency artists. Funded by the Schaufeler Foundation, we are currently exploring our thematic-focused data worlds, socio-technical and cultural syntheses of new realities. A quick thank you to the custody of the TU Dresden for providing this platform through their channel, where you can also find the other interviews from the series. My colleagues already had great conversations with fantastic invitees, which I highly recommend watching. And today I am very pleased to welcome and introduce Eryk Salvaggio. Eryk is an artist, researcher, and lecturer who's interested in the social and cultural impacts of AI. He currently is a researcher at the Meta Lab at Harvard University and a New Ink mentor at the New Museum in New York. And he also is a Gates Scholar at the University of Cambridge for a PhD, where he examines the relationship between archival practices and generative AI. Only some of his many past activities include being an emerging technology research advisor for 4 years and holding several artist residencies, like at the Flickr Foundation or the Max Planck Institute's Machine Visual Culture Research Group at the Biblioteca Hertziana in Rome. He also recently curated Signal to Noise, an exhibition for Melbourne's National Communication Museum. And of course, his own artworks were presented at numerous venues, including, for example, the Centre Pompidou and the Jeux de Paume in Paris, the Photographers Gallery in London, and the Australian Centre for the Moving Image in Melbourne. I think Eryk's blend of professions and expertise is also reflected in his website, Cybernetic Forests, where you can find his artworks, writings, and also a highly recommended, freely accessible lecture series on critical AI. The website also features many of his talks, such as the rather recent ones on the age of noise, in which Eryk explains that we are currently living in such an age and what consequences follow. So I'm delighted that Eryk is presenting some of his thoughts on the age of noise today, before we use this as a sort of starting point for our recorded interview. And the session will then follow the structure of the other episodes of the series, and the Schaufeler colleague will have the opportunity to ask further questions and discuss them in an unrecorded part. But first, without any further ado, I would like to welcome you once again, Eryk, and hand it over to you to present your work. Thank you so much for being here.
Thank you. Thank you so much. It's great to be here. I will share a short slide presentation. So thank you for the wonderful introduction. Thank you for attending or watching later, as it may be. It's a pleasure to be here and to discuss a combination of my research into AI, which is creative research, artistic research oriented. It began as an artistic practice dating back to the internet. As a teenager, I was involved in internet art in the late 1990s and engaging with technology in a critical way, where making was the way that I made sense of the technology. But I was also immediately immersed into a kind of a critical social position to technology writ large, particularly through the lens of the internet. And for me, the practice of making, practice of writing code for interactive websites, or currently working with generative AI and trying to get into the technical architectures and reflect on the structure of the technology itself, is embedded into my artistic practice. The idea of the research that I've done in policy spaces is informed by my work as an artist, and my work as an artist is also informed by my research into the technologies, and it's a complete circle. And so that's a bit of a presentation of my position as to how I view things and how I came to some of these things. And as a result, some of the language, some of the mental models that I have of the technology tend to stray from the kind of normative mythologies that get built up, particularly when we rely on the tech industry to define its own technologies in its own terms. So I'm trying to come at it as an outsider trying to break into the systems, understand the system, sometimes through a what I like to say, and sometimes it overstates the case, a kind of a hacker orientation. Um, and we'll get to some of that in a minute. But I wanted to start with something that I think ties my work to a kind of practice, my artistic work to a kind of practice that applies itself to a kind of media criticism frame, or sometimes is involved in science communication, even as a way of conversing with the public about these tools. And one of the things that I think is really helpful as an anchor is to understand that people, this comes from a marketing research paper. People with lower AI literacy are more likely to perceive AI as magical and to experience feelings of awe in the face of AI's execution of tasks. And so, to me, part of what I'm trying to do is actually remove the imagination from AI. So a lot of artists who are working with AI, and I hold no grudge against them, are oftentimes trying to say, well, I'm trying to expand the imagination of AI. And I think that's totally valid. We want as many diverse definitions and stories about this technology as we can have. But I also think at a certain point, it's helpful to have artists who are saying, here's what the technology actually consists of, right? To strip the imagination out of it, particularly that sort of imagination that is set by the people who are building it and using it to achieve their own ends. And so for me, intervening in this idea of the magic of AI is part of my motivation that bridges that sort of activist, science communicator, artist, policy, weird nexus that I live in and occupy. So I wanted to walk through a kind of example of one of the sort of framings that I work with. So I wanted to present one of the kinds of ways of seeing this technology that is informed by a technical understanding of the architecture of a diffusion model, but isn't often represented. It's not often discussed when we talk about what diffusion models are. We get lost in the language of making an image, or that we kind of say, well, it's trained on all the images online, and then it makes images. But we tend to kind of gloss over, for various reasons, what is actually happening when we say these things. What does it mean to train a model? What does it mean for an image to be training data? And as an early kind of way of trying to understand this, and it has informed a lot of my work, which makes use of noise, which is why you're seeing noise on the screen now. It's not a technical glitch, is that noise is really central to the way these models operate. And when you come at these models from the position that noise is playing an important role rather than just part of the system, it really changes your understanding of what these technologies are and how they work. And so I want to explain a little bit about that. Fundamentally, what we are talking about when we work with an AI image generation model like OpenAI's DALL-E, or Stable Diffusion, or Midjourney, or Grok, for example, which we might touch on in a minute. What we're talking about with these technologies, they're making images, but they fundamentally begin with noise. They start with an image of noise. And when I talk about noise, I mean this in a technical sense, but I'm also going to move to the sort of broader theoretical definitions of noise in a moment. But for now, let's focus on the technical, which is, it literally begins with, for the most part, most diffusion models will generate at sort of the zero step a kind of random pixelization, which is what you're seeing here. Every pixel is randomly colored. It's arbitrarily colored. It is not an attempt to make an image. It is an attempt to create a starting point. And what I compare this to in a way is if you and I were to go outside and look at the nighttime sky and see stars, and I told you that there was a constellation up there, you might see a constellation, but it might not actually be there. But you know what the pattern is, and you know what the stars are up there and how they are sort of sprinkled about. The model is doing more or less the same thing. It's doing that with this image of noise. And it's doing that by referencing training data. So when we talk about training data, here we have an image taken from the Internet Archive. It is an image of a man in muddy pants jumping into what appears to be a lake or a river. And this would appear on the Internet Archive, and it would appear with a description, a text description. man jumping into lake with muddy pants, etc. And what's happening in these models as this image becomes training data is that information is stripped out of it. So we are pulling information about the structure of this image away. And at first, the first layer is we remove information that relates to detail. So the machine is basically removing structure arbitrarily, but that noise is filtering through this image over a sequence of steps in a way that follows a Gaussian distribution pattern. It's not really important to understand how that works. I mean, you can, and certainly it does have relevance, but what is important to understand is that it is following a pattern. And because it is following a pattern, which is a very complex pattern, that pattern can be reversed. So once you take information out of the image, you could go back to the original. And you deploy this over a sequence of steps, you remove more information, and then the computer figures out which pixels have changed following that pattern and traces it back to the original image. And it does this over and over and over again until basically the image is obliterated into an image of noise itself. So in here, you see absolutely no remnant of that original image. But I wanted to point out, at certain stages, we've really distorted this image, but we could still see a kind of structure, right? The rough outline of a man and his pose. That structure is one of the last things to go away because the sort of denser concentrations of color and pixels are one of the last things to disappear through this process. And as a result of that, when you generate an image, the very first thing it does is introduce a kind of rough outline of a structure. And so it is referencing your text prompt, generating a new image of noise, and trying to find the same pattern in that image of noise that it has learned from other images in the training data that have gone through this process that are linked somehow to the text that you've used. So you're describing an image as if it's there. Just like I would say there's a constellation in the noise, here we're saying, hey, this is an image of a man jumping into water with muddy pants. And so it's going to remove that noise, and it's going to adjust those pixels, and at every step, it's kind of showing another image recognition system the image. And at every step, the threshold for that image matching, the certainty that that image matches the text that you've written is tested. So here it might say there is probably a 10% chance that this is an image of a man jumping into the water. Here it might say there's a 15% chance. Here we might say, okay, it's jumped up. It's now a 40% chance. Now, if it wasn't, the image recognition portion of the model didn't say this is a man jumping into water, it might go back and add noise and remove information for that image and then try again, restructure those pixels back towards that sort of center in order to generate this image. So that's an interesting thing. There's a dialogue taking place in the model, an image recognition model saying about the certainty that the image is there, and an image model, part of the image model that is trying to throw more noise at it or strip noise away in order to get to as close to 100% certainty from that image recognition model as it can get. And what's steering all of that is your prompt. And so finally, this goes up to maybe 80%. This is now like 85%, and this is about 100% certainty that this is a man in muddy pants. Probably the muddy has been disregarded because basically this fits the text description close enough. So maybe it's a 90% accuracy, right? And that accuracy can change. So anyway, what is it looking for? Well, if you look at what the image recognition system is looking for, you can look at the actual white papers published about it. So OpenAI has a model for doing this, which is called CLIP. It basically gives a text description of the image that you are shown to, and OpenAI engineers said, what is it looking for? And they looked at what activated neurons that matched with certain pieces of text. And this was super interesting because it tells you in a way what is happening in the machine. And so we see a couple of examples here. We see USA, it looks like George Washington, it has a flag on its head. And if you generated images of USA or Americans, for example, you will see American flags on our heads. You will see basically a lot of things that look like this here on the top left. But I wanted to point to an example that makes it very clear is that all of these images are pictures of people. But if you ask for an image of an Australian, the kind of consensus of all the images that are labeled as Australia, for example, tends to make an image that looks like this. And so if this is what the image recognition system is looking for in the noise, and it's trying to reshape that noise until it looks it's like something that basically looks like this when you prompt Australia. And the result, if you ask Midjourney for Australia, is you get images that look like koalas or quokkas or whatever this animal happens to be. Apparently, it's a quokka, not a koala. But you also see sort of the fuzziness, right? You see a lot of beards in there because it's also the fur, right? So the idea of these two neural networks kind of in conversation creates a tension, and whatever emerges that resolves that tension is the image that you see. That's what comes out of the image generator. This noise structures the image in a lot of ways. Here you see an image of noise at like step 2 or 3, right? At this blur on the left. But if you compare it to the images that come out of the model, if you re-ask the model for an image of a cat or a dog based on this blur, you get the exact same structure. You'll see the feet are kind of in similar places. You'll see the black fur appears on the dog and the cat in a similar place. And if you look very closely at the blurry version, you'll see there's a little blue speckle at the top right of the image, and this becomes the basis of extending it, stretching that until it fits the background, the reflection on the wooden floor or the break in the trees on the dog. So what we're seeing is that noise structures the image. The blur structures the image. In a way, it's like bad taxidermy. The model does not know exactly what a cat looks like. It knows what the shape looks like, and it knows what the patterns are for that word, and it stretches those patterns over these shapes that emerge from the noise. And so here we have bad taxidermy, right? An ocelot that has never been seen by the person making the sculpture versus a taxidermied ocelot by someone who has. And I think we can see oftentimes in the distortions of AI, they actually can resemble bad taxidermy. So let's talk about noise. What about noise? Now, as an artist, I'm really interested in these models because I think there's something really radical about this idea of taking noise and turning it into an image. It's kind of this reversal of entropy. And yet, working with AI systems, I'm extraordinarily frustrated because the resolution is always this center of the data. So if I ask for anything, I'm kind of getting a really kind of average looking, generic kind of visual object. Not to mention the cases which I've kind of elided here is the problematic nature of both where that training data comes from, oftentimes scraped, oftentimes without permission, but also the biases inherent in that data. And I have a lot to say on that, which I'm kind of skipping for time, and because I think people are very aware of these issues, but the biases in the data set tend to be skewed against, for example, Black women. I've looked at the training data for Leon 5B, 5 billion images used to train Stable Diffusion. And if you look for example, girl, you get lots and lots of pictures of white girls, mostly from sort of the Victorian, in Victorian dress, early era photography, public domain images. Whereas if you look for black girls, you get pornographic content or highly sexualized images of adult black women. And this makes its way into the models, right? So there's a lot of problems with models that I actually make me not want to work with things that produce the average of the data in those models. I don't want to see those images. I don't want to share those images. I don't want to work with those images, particularly when I learned that there was child abuse content in the training data, as well as a lot of other quite literal war crimes documented. The pictures from Abu Ghraib, if you remember the photographs that were taken at Abu Ghraib, those images are in the training data, and so it feels very, morally weird, I'll say. I don't know if it feels quite wrong because there is such active transformation, but I didn't want to use that as a source for play and exploration. It felt like we were stomping on a kind of something, we're trespassing on something that I personally have no right to trespass in. So I wanted to explore these models nonetheless. And so one of the things that occurred to me to test as I came to understand these models, is if they're designed to remove noise from an image that looks like this, an image of randomly colored pixels, well, what exactly happens if I ask it to produce an image of noise? In other words, the model is designed to take noise out of an image towards the direction set by your prompt. So, what is the direction set by your prompt if the prompt itself is noise? What is essentially going to happen in theory is that it will remove noise towards some structure which resembles some idea of noise that exists in the training data. And then as it shows the image recognition system, it's kind of asking, is this an image of noise? The image recognition system is going to immediately say 100% that's an image of noise. At which point, the model switches over to start inscribing patterns and structuring that noise, because that's what it would do with an image. Is this a cat? Well, 10% chance this is a cat, sort of rework that, or yes, it's a cat, let's add more detail. So it's trying to add detail to the noise. But as soon as it starts adding detail to the noise in this sort of patterned way, the image recognition system that is designed to encourage it to sort of push towards more detail is going to identify it and say, that's not noise anymore, that is a pattern. At which point, the model will add noise to strip away any residue of pattern or any resemblance to pattern, and essentially it gets stuck in this feedback loop of adding and removing noise until the series of steps has been completed. It's usually around 70. Some models allow you to set how many steps this process takes place over. But for the most part, it's around 70. So you've got about 70 steps where usually it would refine noise towards a detailed image of whatever you've described. But by asking for noise, I've stuck it in this feedback loop. And so what comes out of it is these weird, oh, it's disappeared. These weird abstractions where you can see arbitrary coloration, but also arbitrary, almost like arbitrary structure. There's a tension between the arbitrariness and the structured nature of it. And sometimes I get asked, well, aren't you just creating images of noise from the training data? And I initially assumed that this is what I was doing. But in Stable Diffusion, where an image like this has been generated, you can go in and look at the training data. And if you look for images of noise, what you see is usually references to sound. So you would expect to see like a trumpet here or a speaker, for example, if you were to go solely by the training data. Or you might expect to see just what we saw before, this kind of arbitrary coloration of pixels, which does exist in the data, but you can't train the model on an image like this because the model is going to turn an image like this into an image like this. So it introduces all these kinds of hiccups into the training process, the generation process, and so on. The image recognition process that is built into it. And fundamentally, noise does weird things to technology systems because technology, especially in this space, is about pattern recognition, and noise is the opposite of pattern. And I find this to be really interesting, not just visually, but conceptually, theoretically. So one of the things we finally got to do when ChatGPT sort of added its image generation model to its chatbot was we were able to ask it to do things and then talk about what it was doing. Now, I always say this with the caveat that an LLM cannot explain its own behavior to anyone. It is generating statistical probabilities of what it should be saying. And oftentimes, if enough of the world is describing it a certain way, it's just going to describe it that way. But I still nonetheless found this interesting. So take it with a grain of salt. But I asked it to generate an image of Gaussian noise, that specific type of noise distribution. And it says it can't. There's an error on its end. So I asked it why it couldn't. And I want to read the second section. My image generation system, which leans towards visually coherent, artistic, or photo-like results, isn't optimized for purely mathematical or abstract visual patterns like Gaussian noise. It tries to find meaning or form, and Gaussian noise, being random pixel intensity variations with a normal distribution, doesn't provide that kind of structure. When I prompted it, the I is ChatGPT, the it is also ChatGPT. When I prompted it to generate Gaussian noise, it probably choked trying to reconcile that with its usual patterns of, quote, what an image should look like. And this becomes, to me, the heart of the question, is how does an AI model, which is trained by people, trained on people's data, trained on people's descriptions of images, how does it get a sense? What to a machine is an image supposed to look like? That becomes the question. And what are the limits that we can explore by poking into that and probing that question? So we get this, and I've been working with various types of models trained on more sort of ethically sourced data sourcing, and working with this as an artistic material, working with the noise and the glitch within the system as a kind of artistic material. So here you see a few of the more abstract images. And there is a theoretical sort of concept here. So I want to read a bit from Aaron Zwincher, taken from sound studies, who just talks about noise as that which always fails to come into definition. The question of noise and who has the right to define it is found at the center of the power struggle between succeeding generations, between hegemony and innovation. Noise is found both in the clamor of the unwashed masses and in the relentless din of progress and construction of the new. Noise is found in diversity and confrontation with the unknown, the other, and the strange. Noise is in structures of control and domination, as well as in failures of these systems and their inability to be holistic or totalizing. Despite these forms of noise, noise is not a consonance of opposites, but rather a troubled unity, a unity that does not synthesize without remainder. So this is Aaron Zwincher writing in 2019 before AI models were using noise to operate, and yet he is talking about it in precisely the same way. There's other literature about noise. Cecile Malaspina writes that noise finds parallels in psychoanalysis. It is the overwhelming freedom of choice, this kind of mental noise that we have as a result of these challenges in making decisions. Noise images, the types of noise images that I have shown you, I hope represent glimpses of a still unmodelable possibility, a reminder or even an artifact of a computational confrontation with what might remain uncomputable, at least in the structure of this system. And so I am interested in the human and computational confrontation with noise and the assumption that noise reduction in computation, in psychology, and in politics is an appropriate goal. Noise interests me as material within and against AI as a kind of political project, as well as a kind of technology, as it is disturbing the implicit logics of various models, and it reminds us of the untamed wilderness that resists reduction to regimes of datafication. Essentially, what we can model we call data or signal, and what we cannot model we call noise. And so, to kind of conclude here, I propose that we are no longer in the information age, where information and signal is the most valuable and transformative resource. Rather, we are in the age of noise, and we are increasingly seeking out ways to reduce the flow of information and to have it managed on our behalf. Algorithmic systems are our filter. They are providing us with tools to control the information flow. And generative AI, as we have seen, is a noise reduction technology. It is built on the principle that we should remove the noise at the periphery in order to emphasize central messages and central tendencies that are embedded within our culture. So to remove noise is to tame that wilderness of possibility. To automate that is to tame our own ability to explore and make sense of the world, its arrangements, its people, its politics, in ways that transcend our dependency on previous patterns. So to go back to the original sort of paper on noise, Claude Shannon, greater freedom of choice, greater uncertainty, greater information, all go hand in hand. Before we move on, I just want to show two more quick examples of how noise enters into the sort of work that I make. And I wanted to show an example called Because of You. This is a piece where I tell the story of Henrietta Lacks, whose cells were taken without her permission back in the 1950s. She was an African-American woman. Without her knowledge, consent, or permission, her cells were taken. She died shortly thereafter, and her cells went to a laboratory where it turned out they reproduced endlessly. They had a kind of mutation that allowed them to be perpetually reproducing, which made them ideal as a test subject, as a biomedical test subject. And so lots of scientific advancements came out of these cells, but they were mislabeled, misidentified. No one ever gave her credit for her own body, in a sense. Her family didn't even know that it was their relative, their mother, who was contributing to these types of scientific breakthroughs. And in this piece, I talk about that erasure of identity that comes with the datafication. There's a reference, of course, to training data being scraped from social media platforms without our knowledge and consent. But there is also something about that reduction. And so in this video, we see the image of Henrietta Lacks cannot be reproduced because there aren't enough images of her. She was not a famous person. She was a poor African-American woman whose cells were used, and so she is not well documented. And so if you ask AI to generate an image of her, it just creates a black woman from 2024. So it knows some things about who she is, but not everything. And it reduces her to a kind of composite based on contemporary data. And so it's narrated as well by my collaborator on the project, Dr. Avijit Ghosh, who in the video is speaking, and he has this very precise North American accent. But as he is narrating the story of Henrietta Lacks, he reveals that actually what you're hearing is an AI model trained on his voice, but also trained on a chorus of North American training data. And therefore, his accent, a Bengali accent, has been completely eradicated through the process of generating this model on top of all of that North American training data. And so we explore the question of identity, what's filtered out, what's included, and so on. And it is also a way of using the tools in order to comment on that process, to reflect on how the tools themselves that I am engaging with as an artist shape, constrict, and confine certain forms of expression. And so it's been written about before. Milena Ivanova's paper on AI, art, and morality basically describes the work as the artists beautifully convey the reasons for our moral opposition to AI art by highlighting cases of data exploitation and undergoing themselves erasure in the process of creating their piece. The work manages to capture our moral concerns and bring them to the surface, while the very possibility of this work involves the implementation of AI and the use of data, directing us to engage with the tension and discomfort at the use of the technology to create the piece. This resistance, discomfort, and then meaningful engagement with the piece, which utilizes a technology we can see as morally problematic, can be taken as an example of morally problematic aspects of the artwork constituting artistic merit rather than flaw. And so to me, it also speaks to this noise metaphor. Wherever there is tension, wherever there is friction, there is a kind of noise. And to exist at that point is where I think the art becomes really interesting to make and work with and hopefully to see. So on that note, I'll come to an end. I've gone past the 20 minutes as I promised. So we'll leave it to questions and hopefully more time. So thank you very much.
Thank you so much. That was already very rich. You've kind of touched on many points that I would like to talk about more, like understanding the functionality of AI when you talk about diffusion models as a noise reduction tool, or using noise for creative output, like actively asking it to produce noise, and thus sort of challenging the actual function of AI. But I would like to come back to these aspects of critical AI literacy and your creative practice later, and first address something that sort of runs through your work, which is your interdisciplinary background. So since we at the Schaufel are also an interdisciplinary colleague, I was wondering, firstly, how important you think this multi-perspective background is for your respective professions in general, and maybe more specifically, what role does it play for you in dealing with AI or understanding technologies like AI? And secondly, sorry, that's a block of questions. Especially with regard to the widespread use of AI technologies in the art world in the recent years, would you say that the requirements, opportunities, and difficulties for artists have changed in terms of know-how, accessibility, financing, etc.? And Do you maybe also see dangers in this, for example, with regard to collaborations or dependencies between big tech companies and artists?
To get to the last point first, I think this question of complicity is a really interesting one, and it is one where I think AI artists such as myself have to acknowledge that if we are using these tools, there is a degree of complicity there. And I think that this, again, this idea of the noise, right, is part of that. We are existing in friction, we are existing in tension. And we can either rush to resolve that tension, or we can stay within the ambiguity and feel out the kind of structure of it and see where we can go, where we can push, where we can pull in order maybe to reveal these underlying aspects, as you said. And also, I think to kind of push the medium into different directions, which is also very important. But there's a piece of it where, as an artwork, to speak about the interdisciplinarity, that approach of sitting with the tension of the technology allows me space, time, and a kind of creative flexibility to engage with these systems according to an emergent narrative instead of the narrative that's imposed onto them. So one of the big sort of myths that I talk about a great deal from the AI industry, for example, is this myth of intelligence in the system, right? It is called artificial intelligence. And yet, it is specifically, if we're talking about, for example, a large language model, it is specifically dealing with the manipulation of language. And now this link between language and intelligence is kind of abstract. It's kind of arbitrary, but it is defined as intelligence. The tool is deployed in all kinds of situations that are unsuitable to the task for that the system is actually designed for. The system is actually designed to predict the most likely text. Sometimes that resembles truth. Sometimes that resembles referencing, but oftentimes it doesn't. And fundamentally, it's not a question of just getting the words right. It's the mythologies that emerge when the words are inaccurate. When we say this language production system is intelligence, we're really kind of saying we can imagine a whole host of things, a whole host of situations in which it would be appropriate to generate arbitrary language within a confined sort of set of rules. Whereas if we think about that as thinking, if we think about that as reasoning, if we deploy it to, for example, write an accountability report, which I've seen governments do, that is not accountability, right? The machine cannot atone for a mistake that a government has made. Likewise, we see it when the shaping the conversation, and I promised I would talk about Grok. Grok currently is undressing users of X, right? Now, I just did it. I just said Grok was doing it, right? Grok is not doing it. Users are doing it. So too are the designers of Grok who are allowing it to be done. There are a lot of things which are being sort of blamed on the black box nature. Oh, we don't know what it's going to do. But there are so many guardrails built around this thing that can control what it's going to do, or at least structure the output to those limited, sort of constrain those outputs to a sort of limited space. So this imagination, I think, this interdisciplinary way of thinking helps us sort of challenge that embedded industry logic that is basically trying to sell this thing for as many purposes as it can. In many ways is not cynical. In many ways is a, I think, earnest belief that this is a form of intelligence, that we were on the path to AGI. Sometimes it's cynical, but there is a definite aspect of Silicon Valley culture that believes in this. And so as an artist who's engaged with policy, I'm also sort of being able to say, but as an artist, this doesn't make sense. I actually know how these tools operate. I actually have to get in there and I have to work with them. And I can see, by imagining it a different way, a different set of consequences to the technology. For example, I don't know how you get to artificial general intelligence when you're looking at a large language model, when you're looking at a diffusion model. For example, I don't see how you justify a race to against China within the United States government. This is in Europe as well, which is dominating the discussion about AI investment, taking the rights away from copyright holders, etc., to say, well, we need every drawing of SpongeBob that we can find in order to beat China, right? We have to take copyrights away from artists in order to beat China to AGI. I don't see the link. And as an artist who understands this, as an interdisciplinary thinker, I can challenge those types of narratives. Long answer, sorry.
It was a long question.
Okay.
So you already kind of mentioned what I was going to say next, so I'm just going to phrase it less as a question. I think what I witnessed or what I thought was interesting is that there are various artistic approaches to AI, which was also reflected in those large scale, early, and in some cases very heterogeneous exhibitions, I think. So you have this artistic approach that's very open and curious towards AI that you also mentioned in your introduction. Then there are some very critical approaches refusing to use AI, and then there are critical ones that use AI. So there's this really nice quote by the famous media or especially video artist Namjoon Paik, which I think you also used somewhere on your website.
Yes.
It goes, I use technology in order to hate it more properly. So hate
Yes.
is maybe a bit of a strong word, but I think it's interesting how you also described that you have to get in the technology and work from within. And there are these many metaphors coming up from fields of biology and computing, such as parasite, bug, virus, and of course, glitch, that has been rather prominent in the recent years, I feel. So that's really an interesting observation, I think. And I think from there we have the perfect transition to talk about your work on critical AI literacy a bit more. And so you did a lot of research and writing about myths surrounding AI. You already mentioned them
Hmm.
briefly, and you have summarized them under different sections, like the myth of control, myth of intelligence, myth of futurity, etc. And you recently also added the myth of productivity. So I was wondering, could you explain this a bit more in depth and which myths were perhaps more dominant or relevant 2 to 5 years ago, which are dominant now? How do they get reinforced? And which ones are we maybe as a society least aware of or also could be endangering our democratic values?
Hmm. Certainly. So yeah, indeed, I think I've talked a great deal about myths in the sense of they are useful heuristics, useful tools for explaining the technology to ourselves. They are also powerful in how we approach the technology. And so early on, there was a lot of this conversation about what AI was going to do. This mistake of language for intelligence is still very prevalent. I find it, just to speak kind of briefly about myths in general and why they matter, is we oftentimes, I think, especially in academia, we talk to other people who are thinking about AI all the time. And recently, I've been doing a kind of discourse analysis on Reddit and how Reddit thinks about AI, for example. And you see the public's understanding by people who are so dedicated that they are posting to a subreddit in favor of or against AI and get it talking about it, right? This is a hobby at the very least. The understanding of what AI is and how it operates is still rooted in these original sort of founding myths of ChatGPT, which is that it has learned from the data, which is not true, right? It has learned the structures of language from the data. It has not learned facts. There's sometimes, as I said, an alignment. Again, I don't know how much of this I have to explain to this group. I'm sure most of us are aware of the limitations of LLMs in reasoning and so forth. But this description has really set imaginary on fire among a lot of people about what this technology is going to do for everyone. And sometimes that is a very well-intended idea. But even this idea of artificial general intelligence, for example, where we have one machine that we can ask all of our questions to, and it will tell us how to manage our resources, etc., fundamentally is the eradication of democracy, right? It's an autocratic system. I'm trying to make a pun with auto, but it's not going to work. But it is an autocratic system. So these myths have dangerous conclusions, I think, but they are also really powerful in shaping and misshaping, distorting our relationship to the technology and our understanding and the story we are telling ourselves about what it is doing. And so, for that reason, I've been really sort of keen to explore them as myths, as useful stories that fail, and where those failures are. Um, so, yes, I hope I think I explored your question more than answered it, but yeah.
Yes, yes, thank you. I think it's really interesting how these myths relate more, or it seems like they relate more to the functionality of AI systems and how we interact with them rather than the direct product sometimes, like a generated image. So
Yeah.
I would maybe like to dive deeper into the product of AI systems.
Yeah.
You also use the metaphor of ghosts a lot, and you wrote a great three-piece article about ghosts staying in the picture. Could you maybe explain to us a bit more how infrastructure and archives and biases and training data sets produce what you call ghosts?
Yes. So this was part of a research project that I was able to do thanks to the Flickr Foundation, the nonprofit arm of Flickr that is looking at managing Flickr as an archive. I am a lot of my work deals with that transformation of archival images in particular into training data and then what comes out of that training data. And so with Flickr, one of the things that I was able to explore is there's this photographic form known as a stereograph image or the stereogram, which is basically it's the kind of two images side by side. One is slightly ajar to the other, and as a result, you put them about a foot away from your face, and you it appears as if it's floating. It appears to have dimensionality. Now, these were very popular around the 1890s, 1910 period in the United States. They were the dominant way of distributing images during that time. And if you go into Midjourney specifically, I went into Midjourney, and I expect this was true, I think, also of Stable Diffusion. What you saw when you asked for just the word stereogram, if you think about that as an infographic, right? If you think about what it's producing as a data visualization, telling you what's at the center of all of the data associated with this term, which is how I approach these images, then you would think, well, what I would see is kind of what's at the center. We would see the kind of structure of the image, the side by side sort of image with like a slightly adjacent or sorry, slightly skewed version of the same picture twice. And what I found was that was true. That did held up. That was consistent. It did learn that as a pattern in the image. But what it was also doing is, regardless of any other prompts, is it was kind of structuring a very kind of colonialist view, a colonialist gaze. It had significant sort of pose photographs of people with darker skin tones posed in front of these sort of colonial structures. You saw very wealthy people with like long hair and fancy dress and umbrellas walking amongst people with darker skin tones surrounding them, etc. So now, obviously, we would say, well, of course, in hindsight, we could say, okay, well, this is what was trained on, right? This was trained on images from the 1890s to the 1910s. But when we look at the training data, we actually see that some of the material available specifically in the training data associated with this word stereo view or stereogram comes from the Library of Congress here in the US and an online exhibition of stereogram images and how they were used to sell this story of the colonization of the Philippines, which was occurring at the time, which was that we are educating people, right? And so now we get this image of people with darker skin tones in front of schoolhouses in the AI generated image. And now, if you were not aware of that history and you simply were asking for stereo view images, and I don't want to overstate the sort of media role that this plays, right? But I want to emphasize that what we are seeing is the colonial gaze is part of that prompt for the stereogram. And what I wanted to do was not necessarily to say, like, we need to panic about people prompting for stereo view images, but more that this gaze, this structure includes this kind of politics of the image that can be embedded on the generative side. So that was this idea of the ghosts, right? The ghosts that were sort of in these images, how they were seen, no control over how they were portrayed, are still portrayed in that way of the colonized view, of the colonized gaze in AI models. And if this is happening there, where else is it happening? Which is part of also that piece because of you, which is that eradication of identity and which gaze is centered around the words that we use, around the images that come out of those words based on the training data treating the training data as an archive. There's an interesting way of thinking about this as digital humanities run in reverse. All of the sort of assumptions you make, all of the simplifications you make in creating an archive are now the source of production. And all of the gaps that you introduced in reduction and describing those images are now filled in by an algorithmic average. And so what we are seeing is a digital humanities pipeline that is essentially backed up. It's now flowing in the opposite direction that these tools were built for. And we're always problematic and we're always engaged with critically, but now we can't critically intervene because for the most part, how the model is doing that is unknown, and how we can shape that is not a lever that we have access to.
Thank you for explaining. I think the stereogram is a really good example for how this relation between archives and Gen AI works. You already mentioned infographics as a sort of keyword also, and you expanded, I think, upon that idea of ghosts in the image, or that one needs to know how to look at an AI image to understand it correctly in your paper, how to look at an AI image. And there in the paper, you highlight this importance of understanding AI-generated images as infographics that contain, I quickly quote, layers of cultural and social encoding within the data used to produce them. So I was wondering, could you explain a bit further, maybe also using as one example again, which visual or aesthetic markers provide this insight into these underlying processes when viewing a generated image, and maybe also how GANs, generative adversarial networks, and diffusion models differ?
Mm-hmm. Sure, yeah. I can speak a little bit about my introduction and also emphasize the way that my position as an artist led me to a kind of critical understanding and actually a policy relevant understanding of early image models called GANs, generative adversarial networks. With generative adversarial networks, you had to go out, you took 500 pictures of something, and you could then generate 500 more images of that thing. It learned the patterns. You had to photograph it very precisely, and then you could generate more of those very precisely staged images, right? So it was very limited. There's no text prompting. I mean, there was towards the end, but early on, that was where I started to explore the work of artificial intelligence and images. I would take my own images, or I would use data sets, and I would kind of fuse them incorrectly to see what resulted. But one of the things that became really interesting to me was generating faces. And so there was a website called This Person Does Not Exist. It was trained on a model called StyleGAN 2, or was a model called StyleGAN 2, which was trained on Flickr photographs. And I went in and I want to create diverse faces actually for a Wikipedia article about AI images at the time in 2018, 2019 or something. And I was generating faces. At the time, you hit a button and it just generated images, and you had no control over it. You just hit stop when you wanted it to stop producing images. And I wanted diverse faces, and I found that I could not generate an accurate image of a black woman. And I became very curious about this. And so I went into the Flickr data set, and I found that actually Black women were almost non-existent in that data set. There were about 400,000 images in there. I downloaded 40,000 and then reviewed 4,000. And in that 4,000 that I randomly selected to review, 0.03%, I want to say, were Black women. Now, this reflected the biases of people who were using Flickr. It reflected the biases of people who uploaded to Flickr, who people photographed, this kind of thing. And what became really interesting is not only in a sense, like, who cares about faces generated by an AI model and who's in there, right? Like, it's at the time it was kind of a niche thing. But what was really relevant to me is that while I was working in a kind of policy space, I was looking at papers on surveillance models, and I found that surveillance models were being trained on the exact same data set, the FFHQ data set of faces. And lo and behold, they were also terrible at identifying Black women's faces and then increasing sort of Black men and so on. And these were the exact same problems that were in the surveillance system, were the exact same absences in the data set. And so there's a real reason to think about what is being generated from these things, right? Because it allows you to see the training data itself and the problems of representation in that data. Now, with GANs, it actually led to that surveillance system being essentially disabled. So Oakland police were using it. They could no longer use it. They were arresting people who were not where they were supposed to be according to the camera. Diffusion models, which I kind of explained earlier, right? We made this jump to diffusion models, which breaks images down into noise and then reconstructs them. They're a very different system, but they are still trying to convert noise, or at least that is the new part. The similar part is that it's trying to structure an image based on the average in the data. And what's unique about diffusion models is it is not a problem solved by diversifying the data. What it reproduces is more the single thing. If it's 51% of apples are green apples, it's going to generate green apples 90% of the time. Even if you had 49% red apples, right? It is trying to find the majority and skew the image to that center of the majority. It is not an issue of diversification, but also to speak about that noisy bit, and I'm sorry I'm going on a little bit, but to speak about that noisy bit is sitting in that tension. If you were thinking about it just through that lens, you might say, well, we need to diversify the data set. But if you're diversifying the data set, you're then also essentially creating better surveillance systems. And in theory, a better, quote unquote, better surveillance system is then deployed in ways that have real sort of social consequences. They're going to be more likely to be deployed in areas of poverty and so on. And so this issue of trying to resolve questions of representation also leads to better surveillance. And there is a real tension there. Whereas I don't want to run in and solve one problem without understanding how it connects to this web of other problems. Um, yes.
Yeah, totally. It's a dilemma. I think looking at the time, we should move on to your artistic practice a little bit, because I think it's really interesting how your sort of key concepts are in your scientific work, but also in your artistic work. So you developed some strategies for what you call creative misuse of AI. If I understand correctly, this is your way of using AI systems in ways that were not originally intended and thereby sort of revealing and testing these limits of the systems. Is this correct, or can you explain it further, how you approach this?
Yeah, I think it's correct. So it came out of internet art. So I was working in the 90s and was very interested in usurping the power of the browser. And so there were other artists who were working in similar ways. And John Ippolito wrote a really interesting article, which I owe a lot to, about myths of internet art at the time. And one of these was basically advocating for the idea of what he called creative misuse, which he was a scholar of Nam June Paik as well. And so he tied this to this idea of disturbing the kind of structural embeddedness of the ideology of technologies. The glitch kind of gets in there and it strips away that ideological layer that we usually interact with, the interface, through the interface. So the interface tells you a certain story just as much as the industry, press, and media does. The interface for ChatGPT, for example, pauses deliberately to make it look like it's thinking. Sam Altman bragged about that as a design choice. There was no reason for that to happen. It's there to give you the sense that it is thinking about what it's doing and therefore that you can trust what it writes. That's a design decision. So things that can get under the surface of the interface or under the surface of the overalling mythology around it, and preferably both as far as I'm concerned, I consider a kind of useful creative misuse of AI systems. And so that involves glitch. It can also involve works that sort of show the biases inherent in the system in order to comment on them or reveal something about the product coming through. There are multiple ways to engage with this, and the paper that we wrote, I think, as part of our collective ARG, the Algorithmic Resistance Research Group, we did a show at a hacker convention, which is a whole weird story for another time. But the White House was involved, and it was a really interesting event. But it was very much the mythologies of the industry were still highly prevalent, even in that context. And so even just being there to show that work and to sort of skew that work a little bit or pull apart those mythologies a little bit, I think is an extraordinarily useful thing for getting the public more involved, the public better informed, and also just to reveal the limits of these systems in any way, shape, or form.
Yeah, thank you for explaining. You get really concrete about naming these strategies. So maybe can I ask about them a little bit more in detail, like prompt
Sure.
injection,
Yeah.
repurposing, confusion, and more. So could you maybe explain one of those strategies a bit more?
Yeah. So prompt injection, for example, one of the things that we are arguing in that paper is that artists are very good at being creative and getting around the safeguards of AI models. And if artists can get around the safeguards, then it reveals the limits of those safeguards. And so one of the things that we engaged with was prompt injection. There's some interesting ways of playing with that, sort of using the prompts. The noise prompt, for example, is one of those things where you confuse the system. There's another artist, Steph Madge Swanson, who is very famous for creating this thing called Loeb, which is this sort of demonic figure which appeared in AI generated images that she had prompted. And that was through understanding how negative prompting worked. So basically, typing a prompt asking the stable diffusion for the opposite of something takes you to not the opposite of the thing. So in other words, if you ask for opposite of a rainy day in stable diffusion, it does not give you a sunny day. It just gives you images that are from the opposite points in the latent space or the vectors, basically the opposing vectors to whatever's in the position for sunny day. And so by asking for the opposite of Marlon Brando, Steph got the signs. She used the word language on the signs to generate images. And so she was able to access parts of the vector space that the model could produce images from that were not directly accessible through language, but more through this sort of nonsense language. And therein, this demonic figure emerged, which I would argue was evidence that she had reached some part of the latent space that was associated with gore and violent content that would otherwise have been inaccessible through censorship, either at the prompting level or by reversing the generation after it's done. In other words, censorship. The model produces an image, and then image recognition says that's gore, censors it. She was able to circumvent that. So there's something to this, I think, of artists being able to reveal harms within the system that can then be exposed and corrected rather than letting someone who can actually create real social harm with these models. Since then, that was, I think, 2022. Since then, we found that actually social harm is not a concern of these companies at all. They are not engaged, right? Like many of these companies have no, Grok has no interest, right? X has no interest in censoring Grok. They are not going to do it. And so these sort of circumventions are now actually just, they're not abuses of the system, they're just use of the system. And so they lose a little bit. I think that would be less interesting. I mean, I was really interested in coming around content filtration just to show how it could be done and generating work that escapes that moderation and those moderation policies, using that sort of work as a material. Now it's just the thing. Now you just undress any person who posts on X if you want to, as long as you pay for it. So this subversive element of the misuse is now a kind of a dominant sort of use case. It's just straight out abuse, not creative misuse. And so it becomes much more difficult to thread the needle.
That was actually like one of the next questions. If you would see this more like as a creative extensions of the uses of AI systems, or primarily as a subversive, disruptive tool, or something in between, or how this changed. But yeah, thanks for already
Sure,
answering.
sure. Yeah.
So I think your conception and the use of noise in your artworks, like Human Movie or Because of You that you showed in the introduction, could still also be understood as a strategy of subversive practice. And closely linked to this understanding of noise is, as you have already mentioned, the glitch. And I think this perception of the glitch coming from this former technical malfunction basically being a computational error to this deliberate disruption in today's critical practice is really interesting and can also be found in a lot of other works, like Moth Glitch, your work. So I was wondering if you could explain a bit more, maybe also referring back to the introduction, this potential that you see in this understanding of AI as a filter for noise and asking AI to produce noise at the same time,
Mhm.
and the potential and maybe also limits of using noise and glitches as an aesthetic and disruptive device in artistic practice, and how you think this stylistic devices can help us develop a more critical understanding of AI.
Um, I think we're at an interesting juncture in that since I've started talking about the inability for these models to produce images of noise, they have kind of trained them to do so. And so now noise, rather than referencing actual noise, seems to have been trained. I know that ChatGPT has started switching to a statistical model for image making, so that if you ask ChatGPT now, there is a chance it'll tell you it can't, and there's also a chance that it will simply switch to this graphing model that it has embedded and will then graph random pixels, right? So noise as a kind of evidence of the shortcomings or failures or limits of the system is kind of it's still there. It still is a complicated piece of the infrastructure, but it is less visually evident in what it can and cannot do. So, for example, we know what's happening in that model is that it's a switch, but basically at certain points now the AI can produce noise, right? They figured out a way. So there's a really interesting aspect to this, and there's another limit to it, which is that if we argue that like the AI model cannot produce noise and then it can, we're basically sort of in a race against the technology. And I think people are probably familiar with Leif Weatherby's writing. Leif Weatherby talks about a remainder humanism, which I badly paraphrase as saying basically humanity is increasingly defining itself against whatever the current version of an AI model cannot do, and what a mistake that is, what a limitation that is. And so I want to avoid the idea of the glitch and the idea of noise as that. But more so, I'm interested in the idea of noise as saying these are systems that are trying to reduce the world to a certain perspective, to a certain center. That is still true. That is still the logic that exists in the design of these systems. It is still the logic that exists when you say these systems, not necessarily diffusion models, but large language models are also filters in a way when you look at them. Noise would be defined differently. It's not an image of noise, but it is random values that are assigned to language that are over time, over training, converted to a model of language. But you're always working with essentially randomization that is turned toward signal. And this structuring of the signal, if someone is saying, yes, that is the signal you pass on to the user, you are operating a filtration system. And so the idea is if we are filtering, what are we filtering for? What are we defining as noise? And how does this shape all kinds of aspects of our conversations, social media conversations, what gets deprioritized in an algorithm, what gets amplified in an algorithm? Conversations about all kinds of things can be understood through this lens. And I really want to understand AI through that lens as a source of control. It is not necessarily that it is liberating us from decisions, it is taking decisions away. And that is where it becomes a risk. And so I want to challenge and reveal that kind of point of power and shape, or the power to shape, that these models occupy or possess, and be careful and wary of giving too much to that, giving too much to that system, which is optimized by people to produce certain kinds of outputs that they are defining as appropriate. That's the level that I want to engage with the glitch and the noise in these systems through, as opposed to saying, ha ha, the AI can't make noise and we can. Um, that I think is too limiting of human beings in a way.
I think that's a perfect ending, actually.
Thanks. Great.
And we kind of came full circle back to the introduction again. And you also showed in your last comment how fast-paced these technologies are and what we should ask from them or what we shouldn't ask or where the focus might lie best. So with that, I think I would like to end the session here. Thank you very much, Eryk. It was great. Thank you for your time, for your insights, for the conversation. I had a lot of fun and I have a lot to think about. So thank you very much.
Thanks for having me.